See, Python is considered to be a functional programming language. A functional programming language. Functional here means actually we can use the functions to do means a series of functions we can use to do our activities. That is the functional programming. It is not the procedural-oriented programming. In procedural-oriented programming, what we do is we divide the job into functions and divide the main task into several subtasks, and each task is developed or solved with the help of a function. But in functional programming, what do we do is we use a series of functions to do the job, not a set of statements. So that's so normally if you take the Java, C, they are object-oriented languages or procedure-oriented languages, but Python is object-oriented, procedure-oriented, and also functional programming language because it has that ability. So here, suppose if you take, we are, as I told you, we are performing one sort operation, sorted function. So when you take this sorted function, we give some data here. We give some data, which is collection, and normally this sorts the numbers in a standard way. That means, suppose if it is numbers based on value it takes, if it is strings, strings are alphanumeric data based on the ASCII value, the sorting is performed. Now I want to do that sorting in a different way, so I can take sorted function. Now I can mention how this sorting should be done. I'm not writing a series of statements. So here, with the help of a, we have seen keyword arguments. Keyword arguments are the ones which we pass the value with name. So for sorted, there is a keyword argument called key. Now key, what it does is it takes some function. Now, what this function does is it decides how sorting should be done. If I don't pass this, the default sorting is done. If I pass some function, that function may be library function or our own function or Lambda function, whatever it is, this decides how the sorting should be done. Now, instead of writing a series of statements, I'm passing the function as parameter to some other function to decide the actions in that function. So this is a kind of functional programming. So that's what that's where the Python is powerful. So the another feature which makes the Python powerful is functional programming, because it makes the things simple and very powerful. So I'll take the examples here. I'll take the examples like I'll take list of words. I'll take the words like 1, 3, 4, 5. Now, what I'll do is I'll sort them. So I'll exclude this. Now I want to go for default sorting. So it is getting connected. So I'll say sorted means I'll go for default sorting. I'll not mention how to sort. I'll just allow sorted function to do in its own way. So it will do sorting based on the ASCII characters or alphabet or dictionary order of the words. So 5 comes first in the dictionary order, then 4 comes next, 1 and so on. That is the order it is done. Now same thing, suppose if I take the numbers, suppose if I take one more LST, I'll take num. So I'll take 45, 23, 49, 12, 87, and 33. So 33, 50. So if I have set of numbers, so if I sort them based on the value, it will sort. So numbers. Sorry, I have to exclude this. Exclude this. So it is sorted. Suppose if the same numbers are available as strings, so same numbers are available as strings, then you can observe how sorting happens. So here I'll take it as S nums. What I'll do is I'll just make them as string by keeping them in double quotes. Here there will be difference. It is not normal sorting. You can observe how sorting happens. So I'll take this. I'll take two more numbers with the different values. Like I'll give here 9. I'll give 145. I'll give something like 10. Something. Now, if I sort this, I'll get the order like what do you expect. So I'll get the order like what we expect. So 9, 10, 12. Now I'll add this whatever additional numbers I've added as strings. Now when we take this, you will get a different order because it is not based on the value of the data, but it is based on based on ASCII characters. So based on the ASCII characters, you get it. Suppose if I sort the numbers, so if I take these numbers, somewhere some mistake here. Which is not valid has come. Okay, I'll try to do this. So now I'll take this. Okay, now I'll sort them. So when I sort these numbers, which are available as strings, you will get like this. So first you will get there will be first you will get. First you'll get 1, 0, then 1, 2, 9 will come at the end. So 1, 0, 1, 2, 1, 4, 5. This is the sorted order if I take them as strings, because one occurs first, then afterwards it will take the second character 0, 2, 4, the order, then 2 occurs 3. So this is the order. If I take strings, even if that string content isn't, it takes the ASCII value of those characters and it sorts. Same thing if I take them as numbers, I'll get a different order. So this is the default sorting done by sorted function. Now I want to change this default sorting. Like suppose if I take the strings, whatever I'm sorting. So this is default sorting. What we got is as per the ASCII values of the character, the sorting is done. Now I want to sort based on the length of the string. So what I can do is I can say sorted LST. Now I'm passing a keyword argument called key. Here I have to mention the function using which the sorting is performed. Using which the sorting is performed. So here I'm passing length of the string. So what it does is based on the length of the string, sorting is performed. If two or more strings are with the same length, the same order, whatever there in the original list, that is maintained. Now, if I take 1 comes first, then 6 comes, then 2 comes, because all are 3 character length strings, and 1 is appearing first in the order, so it will get same. Then 5, 4, then you will get 7, then finally 3. That is the order of the string what you get. So 1, 2, 6 based on the length of the string. So that's what I'm doing here. Now this is one thing. Now if I want to do sorting on a different parameter, not default, not length, then I can decide how, as a programmer, I can decide how that should be done. For that, what I can do is I can write a function, and that function I can pass as a parameter to sorted. Then for sorting, it will take help of that function. So for each one, we'll see how differently it performs. I'll take this first, this strings. I'll continue with this. So for this, what I'll do is I'll define my own function called define. Reverse of the string, I'll do reverse str. Then that str is passed here as parameter. Now I'll say return str. So what I want the reverse of the string. So based on that, the sorting is performed. So I'm preparing that function for execution. Now this function I use here in this sorted function. Now I'm asking sorted function, do sorting as per my requirement. My requirement is given in reverse str. So now the sorting is done based on the reverse of the string. So now when I reverse the string, first one is EE, then EN, then EV, then NE. So that's why we are getting this based on the reverse order of the string. The sorting is done. Like if you have confusion, so I'll take this. I'll take these words and write it just for some clarity. So if I take, I'll take 1. Then reverse is ENO, then 2, reverse is OWT, then 3, reverse is E or HT, then 4, reverse is RUOF, 5, reverse is EBIF, 6, reverse is XIS. I think I've taken up to 7. Now 7, I'll get NEBES. Now if you take this reverse, first one I'll get this because EE, alphabetic order. If you take dictionary order, if you take E will get. Then ENO. This is nothing but I'm not asking the string to reverse. I don't want the string to be reversed, but sorting is on reverse. So 1 remains 1, but it will 1 remains 1, but if I reverse it, 3 will come first, but I don't want the reverse string. I want only original string, but only the mechanism for sorting is reverse of the string. So then I'll get ONE, then EV, so I'll get 5 because this is third, so I'll get 5. Then after that, what is N you'll get. So NE, so 7 you'll get because this is the fourth one. 7 you'll get. Then fifth one is OW2. This is fifth one, TWO. Then sixth one is 4. So this is sixth one. Then seventh one is 6. So 4. on 6. So this is how we get it. So the same thing we got 3, 1, 5, 7, 2, 4, 6. So that is the reverse order of the string. Now, reverse order, what I want is I want to keep the here. I don't want reverse order. I want to keep this first character here. Then I want to sort. Like I want to have E, N, O. Only first character I want to move to the first position. Remaining I want to keep as it is. E, T, H, R, E, R, F, O, U, E, F, I, V. Then X, S, I. Then N, S, E, V, E. So in this case, if I want sorting based on that, so which one will come first? I think E, F will come first. So I'll get 5. I'll get 5. Then which one I'll get? E, N, O. So 1 I'll get. Then E, T, H. So I'll get 3. Then N, S, E, B, E. So sorry, 7 I'll get. 7 I'll get. Then what else we get? 5. Sorry, 5 has already come. Then T, W, O will come because O, T, W. Then R, 4 I'll get. Then 6 I'll get. So here the function is different. So what I want to do is I'll take one more function here. The function is I want the first character should be kept in the beginning. Then I want to have the sorting first, last first. I'm naming this as last first. Then I'll take HT. Then I'll say return. So what I want here, return. First I have to keep the last character. So I'll say -1. So if I say -1, I'll get last character. I want remaining characters excluding the last character. So I'll say str colon -1. So excluding the last character, I want to have remaining characters, but last character will come first. This is the mechanism I want for sorting. So now I'll execute this sorted. LST key equals to last first, last underscore first. So now if I execute this, so first 5 like what are 5, 1, 3, 5, 1, 3, 7, 2, 4, 6. So I'm getting the same thing. So this is, see, whenever I go for this kind of thing, what actually happens is, now when I say reverse str or last first, what actually done is, for every string, you can observe, you'll see what is happening. Every string is passed to that function, and whatever way we want to have sorting, that is returned. So what I'll do is, to be more clear, so here what I'll do is I'll just print. So what is happening here? str before calling the before we I'll do for what when, sorry, for which string it is called. So I'll execute this. Now when I call this, you can observe it prints. So first time 1 is passed, then 2 is passed, then 3 is passed. So for every string available in the list, that function is called once. So that's how it is happening. When it is called, it will convert that string into the format what I want, or it will decide the logic how sorting should be done. Then whatever value is returned, that will be the base for sorting. So the sorting has happened like that. So this is how this is a kind of functional programming, because I'm not writing a series of statements. I'm using just function to get my job done. So this is this facility is there in Python, so which will make the things very efficient, and it will make the things simple. So this is one more thing. Now, if I take series of numbers like this, I have a series of numbers. Now, when I sort these numbers, it is taking ASCII values. Now, I have those strings as numbers, but I don't want I know that the string has series of digits which can be considered as a numbers, but when I directly sort, it is taking ASCII value. Now, what I can do is I want based on the I don't want to change those strings into numbers, but based on the digits that are there or based on the value that is there in the string I want to sort. So I'll write a function for that. So I'll say define value in str. So based on the num value present in str, so I want to sort. So what I'll do is I'll simply return the numbers remain same, but the numbers, the items remain same, but for sorting, the strings will be converted into number and it is executed. So now I'll execute this. Then I'll now call it for sorting. So I'll say sorted. I can say what is this snums. I want based on the num value of string. So now you can observe how sorting is performed. What it is. The key I have to write there. Key. I will say key equals to this. So now when I exclude this, so now you can observe whatever we are getting here. So 9 as per the value there. So 9 should come first, 10 will come next, then 12 like that. But here when I take the strings, the digits which are available as strings, I'm getting this order. But I want strings as it is. But the order is based on the value inside it. I don't want to change the string. So this is how we can do it. This is a kind of functional programming where we can do a lot of activities. Not only for sorted, you can do it for anything. Like suppose if I take the LST here. Now when I take LST, maximum of LST is which is the last element as per the dictionary order I'll get. So it is 2. So I'll get 2 as maximum because 2 occurs last in the dictionary order. Or if I take sorting, so what I am getting 2 as last. So the same thing I'll get. But I want maximum string based on the length. So when I want maximum string based on the length, what I'll do is max LST key equals to length. So here I'll be sorting based on length. So 3. So based on length, 3 is the highest one. So I'm getting 3. So that is how the so max function using length function. So I can also do I can do the maximum value based on whatever I want. I can pause reverse of the string here. So reverse can write it again in a different statement. So based on the reverse of the string, I want to find the maximum. So I'll say max. I'll say LST key equals to reverse of string. So based on that, the reversing is done. So whatever last comes based on the reverse. So it is actually printing there. So it is giving 6. 6 is the last based on reverse. So X is the last. So you are getting 6 as result. Why you are getting all strings is because here I am printing. So I'll remove that printing, whatever I kept, because it is just for your understanding. I have kept how that function is called. So it is called for every item present. It is called. So that's why we are getting that result. I'll remove that I'll remove that. What is that? I'll remove this print. I'll exclude now. So now if I exclude, I'll get only 6. So if I exclude this, I'll get 6 because now I have removed, so I'll get 6. So you can combine this kind of functions in a very flexible and powerful way. This is what functional programming is. This is actually a simple kind of functional programming. You can have so much complexity, or you can add user-defined function in user-defined function, whatever way you want, you can add, and you can get the job done. So this is how the Python allows us to make use of functional programming, and we'll be learning much about that. So to continue this functional programming and to make this functional programming more simple, there is one kind of function called Lambda function available. So we'll see Lambda functions. So Lambda function is a special function. Lambda function is a special function. It is a special function. Special in the sense here, it is an inline function. What is this inline function? I'll give you. And this is one thing. Another is it is anonymous function. No name will be there to the function. Anonymous function. And another thing is it is so inline function, anonymous function, but there is a limitation. These are the features. So Lambda function is inline function. Why it is inline, I'll tell you. Anonymous means no name will be there to the function. No name will be there. Then it is there is one restriction or limitation on Lambda function. Limitation on Lambda function. The limitation is only one statement can be present. Only one statement can be present as part of Lambda function. Only one statement can be present as part of the Lambda function. And why it is called as Lambda function is because to create this function, we use the keyword lambda. So normal function, so we'll see the differences between the normal function and Lambda function. So normal function is defined with the keyword def. Def keyword is used with normal function, and with the Lambda function we use the keyword lambda, Lambda. So lambda keyword is used. Now, what is this is one difference. The further, if you take the differences, now if I'm defining a function here. So if I am defining a function, some name of the function, it takes some parameters. So it can have any number of statements. Then this is the function definition. And from here, suppose if I call the function, this is function call. So when function is called, the execution which is happening from here, it will jump to this location. It will continue the execution here. Then it will come back and continue the execution. This is how the functions are executed. So when you are calling a function, suppose if this is the series of statements main program you are writing, like here we have written so many functions, built-in functions, or library, our own functions. So here I'm this I'll take this one. This is one function. This is the function what we have. Now I'll take this also. This is actually the main code. It is not a function. It is the main code. You can say it as a main program. This we can call it as a program. Now I'll add the function somewhere here. So I'll add function. So this is the call statement. Now what happens here is first this statement is executed, then it comes here. There is a call statement. This is call. So when there is a call statement, then the execution which is happening here, it will suddenly jump to this place because function is defined here. Then it will complete the execution of the function. After completion of execution of the function, it will continue the main program from where it has left. So from here jump has happened, result will move into this and the execution continues. This is how the normal function takes place, normal function execution. So when you have a normal function, there is a call transfer. Execution happen call transfer or control transfer. Control transfer means CPU's execution which is happening here. Control transfer happens here from here to here. Then after that, after completion, again the control is transferred. There is a overhead. This is call overhead. Means background, so many activities happens if you know C language or if you know data structure. Whenever you call a function, the local variables are moved into stock. Then the return address is moved into stock. Then parameters are moved into stock. Then it will jump to the function. Then parameters are popped from stock. So these are so many things. You need not bother about all those things. Just remember that background, so many activities happen when you call a function. This is if you take all those things, it is called as call overhead. Some call overhead is involved when you call a function. But when you take this lambda functions, lambda functions are one-liners. So you will see how it will be happening. So the syntax of lambda function, first I'll write, then I'll compare with the normal function. So when you take the syntax of lambda function, so we have to write lambda, lambda, here the arguments. So whatever arguments we pass, we have to mention here. Then colon, then expression. Whatever expression we want to give as a result, that you should keep it. No name is given. So this is how the lambda function is lambda function is called. Lambda function is defined. Now, when you have a lambda function, this lambda function is used as part of a statement. Lambda function. Now, in place of this, I can directly use lambda statement. Now, when lambda function, when I have a lambda function, it is inline to the normal code. It is inline to the normal code. Means wherever normal code is there, inline to the normal code, whatever expression you are keeping, that will be added. It is as powerful as a function, but there is no call overhead. So as part of code, it is embedded. As part of code means inline to the code, it is embedded. So there is no call overhead present. No call overhead. No call overhead is present. So it is executed surely faster because there is no call overhead present. So, but the thing is, it is more readable because here what we are doing, we are keeping the function name here, definition somewhere else. Then to know what is happening in this function, we have to go to that function and go through the statements. But when it is a lambda function, it is inline to the code, the flow. So you can easily understand the function. So the another advantage of lambda function is it is readability is good. Readability is good. You will see how lambda function will be. So this is actually the lambda function. Now I'll define some lambda function and I'll replace whatever we have done like sorted function, max function. We have used some user-defined function. Those in place of user-defined functions will go for the lambda functions. So here I'll take lambda function, but first I'll define a lambda function. So I'll say res equals to lambda or I'll say lambda, then the variable some name. I'll simply return the square. So this is the lambda function. Here I'm just taking the square of the function. Now if I want to use this, whatever return value we are giving, that you can use it. So I can say print res x. Now when I write like this, so I'll exclude this. Sorry, rex some number here, 50. So it gives the result. Now what happens here? What is happening? I'll just briefly explain. Then we'll see the actual usage of lambda function. So this is lambda. I'll take this print statement. Now, whenever I write a statement like this, so what is happening here is the function is not going to be called. So wherever this res is present, wherever res 50 is present, it is replaced. Here 50 is x, it is replaced with 50 into 50. Now there is no call overhead. It is actually inline to the inline to the statement. So that's how it happens. Now, because it is 50 into 50, there is no calling of that function because there is no name. So it is inline to the code. So that's what happens here in lambda function. But this is not the actual usage of lambda function. We don't use lambda function like this. We don't define first then use it. We directly use inline to the code. Like here, I'm taking here like a sorted function. Now we have seen sorted LST. So here it is sorting. Now I'll use the user-defined function like reverse str. This is the function. So there is a call happening. So here I have to say key. Here key equals this. Now the reverse str is called. Now I can replace this reverse str with lambda function, which will be inline. So I can say sorted lst comma key equals to. Now I can use lambda. So this is the usage of lambda. Lambda str. Then I'll say str colon colon. So this is the lambda function. You will get the same result. So this is how the lambda function is powerful. Now you can know that I want to see everything is happening here. There is no call overhead present. I'm using anonymous function and it is one liner. So if it is one liner, you can go for lambda function. So this is what happening. Now if I want to sort based on the last character to be first, then I can do it with lambda key equals to lambda. Equals to lambda, then str, this is str is parameter, then str minus 1 plus str colon minus. So it will do that sorting, whatever we done. Similarly, the words, if I take what I'll do is I'll say sorted. This I told you the digits are there in strings and the sorting happens like this. Now I want based on the value that is there inside the string. What I'll do is I'll say snums. Then I'll say key equals to lambda. Equals to lambda. Then I'll say str. So this I'm getting the result. So this is how lambda functions are useful. So when the logic is one line logic, because in Python most of the things we can do it with one line. If the logic is one line logic, go for lambda function because it is in line with the code. So readability improves and there will not be any call overhead present. So execution should be faster. So this is one usage of lambda function. Will be using lambda functions, then the comprehension, all wherever possible we are going to mix and use. So this is actually the simple demo of lambda function. We'll further go with lambda function. I told you Python is a functional programming language. There are so many powerful functions which are used in functional programming. So the very popular functions which are used in functional programming, we'll see, then we'll mix them with lambda comprehensions and we'll do some programming. So the popularly used functions, in functional programming, popularly used functions, library functions means built-in functions in functional programming. Functional programming, or first one is map. This is one function. Reduce. So reduce. This filter is another function. Then third one is reduce. These are very popular functions in functional programming. Map, filter, reduce. I think map we have already used. We'll go ahead with map because just have used. I did not explain what is map. I told you I'm going to explain this map function later. So once we come across this function, once we learn this function, how they work, they make the programming very powerful and simple because you can mix these functions. Because when I say functional programming, you can just use series of functions to get our job done in one statement. So these functions make the functional programming more effective and simple. So first we'll start it with the map function. So map, what it does is, first if you take the map function, it is very useful function. Map, what it does is, it takes some function as parameter, because in functional programming, it is map itself is a function. It takes again a function, then it takes a collection. It takes a collection. Now what it does is, it will apply this function. It will apply this function for individual item and it returns another collection. So for example, suppose if I have map length, if I say 1, suppose I have a list 2, 3. So what it does is, for every item present in the collection, what is the collection here? The list. For every item present in the collection, this function is applied and the result is returned. When length is applied on 1, I'll get 3. When length is applied on 2, I'll get 3. When length is applied on 3, I'll get 5. So this is the result of this. So this is a very useful function. So map function takes another function as parameter, as first parameter. This function can be any function. It can be library function. It can be built-in function, user-defined function. It can be Lambda function, whatever it is. That function is applied on this collection. Items collection individually for each item. So this function is not applied on the entire collection one time. For individual item, one time it performs. So for each item, that function is performed. So that is the Lambda function. So I'll take this list. So again, now what I'll do is I want to apply map, and I'll say map list length and list. So this is so powerful. I'll print this because it will return a map object which we need to convert that. So we'll see. Otherwise, when I exclude this also, I think it will print the same thing. So now what I'll do is I'll convert it into list. Now you will get the result. So it is so I'll remove print here. I can shoot this result in another list. I can exclude this. So I'll get see I'm getting in a simple way I'm getting length of each string present. So that is so power of so if I take that s nums, I'll take list int s nums. Now this s nums, whatever they're available as strings, now they are available as numbers. So not list. I have to say map. So I'm getting this. So this is how we can do the operations. Now suppose if I want to reverse the string, so I cannot str minus minus is not a function, so I can use a lambda there. So if I want to reverse the strings, I can say map. Then I'll say lambda str. Let's say str colon minus 1. I can pass only functions, so I cannot keep the statements here. Then I have to apply. I'll apply on list. So I'll get all reverse of those strings. Somewhere lambda. So map. So here I should map lambda. So now it is to get this. So it is in simple statement. It will do a reverse of all these strings. So this is how we can do it. Now I want all strings to be converted into uppercase. So what I'll do is so I want strings to be converted into uppercase. So I can say list map str, then str upper. This is the function. Give a list. So this is so powerful. Lambda function is so powerful. So you can apply the lambda function now. If I take one simple question here. I'll take one question. Read a series of numbers. Find read series of numbers separated by space. Among so this is my requirement. So what I can do here is first read a series of numbers. Now data. This is now when I say I'll get what data I'm getting, we'll see first. Step by step we'll do it. Now I'll print this. And what we are getting, I told you how input data comes. What is the data? The type of the data we'll see. So suppose if I take 1, 2, 3, 4, 5, 6, 25, 35, 58, 100, 200. Suppose if I give this, so I'm getting this as a string. So I'm getting this as a string. So next, what I do is I'll separate them into list. So I'll take list data, because when I take this string, I want individual items, not the entire thing as a string. So what I can do is I can say this in data, the split function in we have seen already. Split function will split the data based on the space. Now if I print LST data and type of that, it's a list. So I'll exclude this. I'll instead of typing each time, what I'll do is I'll store in some notepad. So I'll take 45, 93, 85, 123, 145. I'll take this. Now, whatever we enter, it will be available as string. I'll enter this here. Now, it is available as a list and individual items are available. Now, earlier, this is whatever we enter here. Now, if I take this, whatever we enter, this is available. So whatever we enter, this is available as a string. It is available as string. And so it is the string type is string. You can observe here. The type what we are getting is a string because it is available. Here it is displayed like this. Actually, it is in this form. Now, when I apply split, then I am getting the individual. When I apply split, I am getting the individual items. So this data is individual items. It is available as individual items. But now if I find maximum, in this, I'll get 93. If I find maximum, I'll get 93 because it is based on the ASCII value. So I'll get 93. But what I want numbers. So I want it as a number. So if I apply max of that list, LST data, you can see I'll get 93 because it is a string. So this, take this, take this. So it is, you are getting 93. I am getting the result as 93. But I want based on the value. So what I had to do, I had to convert them into LST numbers. So how to convert? I have to apply. What I can do is I apply for each item present in that LST data. So what I'll do is I'll apply int. Now I'll get this in this form. So print LST number. Now if I find the maximum, I'll get the correct result. So LST nums, if I say, I'll get the correct result. Now I'll execute it. So this is the process that is happening. So here I'll print it. I'll print this. I'll print this because it is not coming up. I'll print this maximum. So this is the series of statements I'm writing. Then maximum, if I take as strings, I'll get 93. Now I'm getting 200. This is the series of steps. Now, if I use functional programming, what I can do is I can take input as a function. On that, I can apply split. So I need not move into somewhere. Programming, if I convert into functional programming, I'm taking input. That input directly I'll apply split. So I'll apply split. On this split, what I'll do is I'll apply int for every data item. So I'll go for map. Okay, so input is a function, split is a function, int is a function, map is a function. So integer is performed. Then I'll perform maximum. So this is functional programming. So I'm not writing series of statements, just writing functions. Now I'll get the result. So I'll give the input, I'll get the result. So the result is true. So this is the functional programming. So functional programming, what we are doing, I'm writing a series of statements. This is normal code. This is normal, we can say procedural code because I'm using functions. But if I take the function programming, here except functions, nothing is there. Input is a function, split is a function, int is a function, map is a function, max is a function. All functions are there. So this is the functional programming. This is so powerful in Python. You can do the things in very simple. So here I have written statements to make you understand, but I can remove some statements, but I can write a series of statements to get the job done. But if it is functional programming, this is how we do it. So this is actually the power of Python. So we can use the series of functions and get our job done. So that is how we do it. We can do a lot of programs. Now I'll take one placement related question, which I'll check where it is present. So here. Yes. So where it is. And not this one. So this I think we have already done. Have we done this? this I think we have done. This. Not this. Yeah, this one. This one question we have already done. Another I told you require some more concepts. So this second we have done. First, we require, I told you this map and lambda function we require. So maximum difference between two elements such that larger element appears after the smaller number. So here, if I take larger element 10 larger, and if I take any larger element, so if I take 3 minus 2, I'll get 1. 10 minus 3, 7. 10 minus 2, 8. So in this kind of thing, from right side element, we have to subtract left side element. We have to find the maximum element. Maximum difference between two elements such that larger element appears after the smaller number. Means we have to subtract left side element from right side element, and we have to find the maximum. So this is the requirement. It is one of the some placement. All right. This is question. So sample input. This particular input is 8. So this is the now this data is given. I'll take this data as a list directly, or we can read it from the keyboard. And but I want to take as it is from the list. Copy from here. Data as a list. Now what we have to do is maximum difference between two elements such that the larger element. So here we have to find difference between the elements. We have to find the difference between the elements. So what we have to do here is I'll take input. Okay, I'll take this input. Now, what I'll do is, the logic what I want to do is, I'll subtract, because I'll start from first element, because we have to subtract right side element from left side elements. So, I'll subtract 2 from 3, 10 from, 2 from 3, 2 from 10, 2 from 6, 2 from 4, 2 from 8, 2 from 1. So all numbers except I'll subtract first element from all remaining elements. Then I'll subtract 3 from all remaining elements. I'll subtract 3 from all remaining elements. Then I'll subtract 10 from all remaining elements. I have to find the maximum. I'll do it step by step. Then we'll. So if I find, I can use this because it is because it's. I have to do the same difference on all the numbers. So what I can do is I'll say I'll use the lambda. I'll say what I have to do. I have to find the difference. So I'll use lambda. On which I have to apply. I'll take the first number. So the item I'll take, which is first value I'll take, or I'll take first just for clarity. First I'll take and I'll subtract this. So remaining means here, I'll subtract this from remaining. So the expression is LST remaining. So what are the remaining? 1, 2 remaining minus first. So this is the logic, and the data for this function is, this is the lambda function. The data for this is all values except the first one. All the values subtract. So not first. This is all one by one here item, which is not first. Not first. First is remaining elements. So this is what I want. I'll subtract first from remaining elements. So remaining elements is available as item. So from what list I had to do this, take list from first, excluding first. So I'll exclude this, then you'll understand. So 3 minus 2, 1 I am getting. 10 minus 2, 8 I am getting. 6 minus 2, 4. 4 minus 2, 2. 8 minus 2, 2. 8 minus 2, 6. 1 minus 2, minus 1. So I'm subtracting first from all. So how I'm fixing the first one, which is LST0. Remaining elements from first, excluding first, I'm taking the remaining elements. And that remaining element from the remaining elements, I'm taking one at a time. This is item. So item is available as 3 first. Item is available as 10. Item is available as 6, and I'm getting the result. So I'm getting the difference between remaining element and first element. So this is the difference. In that, if I find the maximum, I'll get 8. So same thing if I find maximum in this, I store in a list. I store in a list. If I'll say LST difference. Then LST different, then print the maximum amount. So map lambda LST. So up to here, I think one bracket I have removed. Now it's okay. Still there is list map that is going up to here. What is the error? One more bracket still is. Now it should be okay. Print LST there L has gone. So I'm getting this. So I'm finding the difference between remaining elements and first, and I'm getting that result, and I'm getting the maximum. But this is only one result. I have to subtract because right side from right side element, left side should be subtracted. Next, what I should do is 3 must be subtracted from a remaining. 10 must be subtracted from remaining. 6 must be subtracted from remaining. So this is the logic. That means I have to repeat a loop. I have to repeat this in a loop. So what I'll do is for I in so except the last one, I have to take everything. So length of LST minus 1. So here instead of first, what I'll do is I'll take LST I. Then instead of here of 1, I have to give I. What I get will see. So when I is 0, 2 is subtracted from here. What I'm doing? Yeah, 0 it is also coming, 3 minus 2, but we don't want that. So here item minus elastic I, here I plus 1, so I plus 1. Now it's correct. So now when I subtract 2 from remaining, I'll get 3 minus 2, 1, 10 minus 2, 8, 6 minus 2, 4. So I'm getting in that maximum is 8. When I subtract 3 from remaining, 10 minus 3 is 7, 6 minus 3 is 3, 4 minus 3 is 1, 8 minus 3 is 5. In that maximum is 7. Then 10 is subtracted from others. Remaining right side element. So 10 is subtracted, 6 minus 10 is minus 4. Because 10 is maximum, so you get all negative. Then 6 is subtracted from 481. When 6 is subtracted from 481, it is minus 2, 2, minus 5. Then 8 is subtracted from 1, I'll get minus 7. So this is how we are in this maximum you have to find. Now, if I write this in one statement means I can take. Yeah, we can do it in one statement. Or if I want to find the maximum, so this is how we are doing. So what I'll do is I'll do find maximum here. So and here I'll take the maximum in some place, and I'll take maximum here. Find the difference. Of this, max of this, mx. Because I want maximums, so I'll take max of list difference. I'll copy this. So mx this. Then finally, I'll print mx. I'll get. So I'll say print mx. I'll get the result. So somewhere some mistake, max. So I'll remove this blocking. We'll see kind of syntax of it. Oh, sorry. Here I have to give colon. That is the mistake. Then print this here. The space is extra space. I'll exclude this. So I'll get it. Now suppose if I change this to 18. Suppose if I change this to 18, what should be the result? I'll get 16. I'll get 16. So I'll get 16. So this is how, suppose if I write this as 1, and if I give this as 25. Okay, let it be. I'll get 22. So this is what I want. So this is we have done with map. Now I can mix this with the list comprehension. I can make this programming very simple. So I'll take this, whatever may be the data. I'll take this. I'll use a list comprehension. Let's say print max list. So what is the list for I? What I have to do? List comprehension. I have to take this. Max. I'll take this. Max of this list. Max of this list. So max's list I'll get which is here. Then for I in range, I'll copy this. The same thing I'll take for I in range. I'm getting a list here. This bracket I should keep here. So I'll get a maximum list here. This needs some error. What it is saying, invalid syntax. Here I'll give one more bracket, range. Now I think it's okay. Now I'll explore. So I'm getting the maximums. In that I want maximum. So what I'll do is maximum of maximums. So that I got all maximum, but I want maximum of maximum. So I'll say max. I'll get the result. So single line statement I'm getting. This all the statements I'm writing into one with the list comprehension. So I'm getting the result as 22. That's what we want. So this is how we can make. Now this entire all statements. Now the if and everything are removed. This instead of this, I'm writing one line statement. Here I'm using functional programming. I'm using the list comprehension. So this makes the programming, but it is not difficult. So write without comprehension, then you can easily convert. You follow, you go through the statement carefully, then you'll understand. Otherwise, I'll try to explain this again. Next class or tomorrow's class, I'll try to explain it again. So this is how we can mix. Now I'm mixing comprehension. Here I'm using comprehension, and I'm using the functional programming. This is functional programming. Up to here it is functional programming. I'm mixing with comprehension. I'm getting to this.